Hello, everybody. Welcome to our last long session of the conference. This talk is What Would You Ask a Crystal Ball for AWS IAM by Nick Slow. And our sponsor for the session is Trust on Cloud. So thank them for making this possible. And as always, we'll be back for Q&A at the end.
All right, thank you. Let's see. This good? Cool. Yeah, so welcome to talk. What would you ask a crystal ball for AWS IAM? And it's end of conference, so hope everyone can muster some energy, and I hope you like IAM stuff. So a little bit about me. I'm currently on the cloud security team at Netflix. Previously, I was at Apple doing pretty much the same thing. My GitHub is there, my LinkedIn as well. I don't know why I put it there. I don't really use it, but if you want to reach me, it's theoretically possible. And favorite AWS services, which is my new favorite icebreaker for conferences like this. Obviously, I am, and big fan of S3 and SQS too. A bit about this talk. So this began as a 20% project at work. The name of the talk is actually the name of a survey that I'd sent out to a bunch of people I'd worked with previously and some other folks in the industry, just generally asking, what problems you have with IAM, like what would you like to know more about? And if you have opinions and want to contribute to my market research, there's a QR code there. But this fed into some internal tooling and projects. I talked to some other people, and generally what I heard back was hard same. Like everyone kind of like runs into this. No one has quite the understanding they would like to have. I'll caveat this by saying it's definitely still early days. Like this is, I guess, technically started in like 2023, but it's taken a long time to start like figuring things out, building out the capabilities, and so I still think we're just like tip of the iceberg here. I also am aware of the irony of presenting a talk about Netflix stuff and saying like, hey, you all have this problem too, maybe at the same conference where Rami said you are not Netflix. I know, but bear with me. I think there's at least some overlap here. Cool, so let's talk about the problem or how this kind of started. So a little bit of background on Netflix, very large cloud environment, very early to the cloud, made some decisions that you would probably consider mistakes today for sure. And we just have a whole spectrum of infrastructure. I say like old as dirt to bleeding edge, and that's very true. Like there are resources that are older than the career of many people here. And there's also stuff that like just came out that we're trying to make use of, and we have every conceivable access pattern. So because of the age, there's often sort of a disconnect between the original intent of how access was meant to be stood up and what it actually looks like today. You imagine doing, deprecating a bunch of role types, doing migrations, taking advantage of all the IAM features that come out, and just doing that over a decade or longer. And you start to get some very interesting combinations of those things and things that just don't play very well together. And so these kind of like archaeological layers of going through things. So the start to this actually has nothing to do with cloud security altogether. It was kind of a little bit of a more boring start. There was a desire to make like an enterprise security metrics program. And kind of what that meant was start building out some metrics for security, gauge how we're doing, and make them very standardized across domains and obviously quantitative. So it was a lot of like requiring simple answers to simple questions, and we quickly found out that we didn't have those simple answers. So this is kind of how I would frame it. The domains that we were working with had a much more straightforward access model. So if you get asked, who can access this Google Doc? You go look at an access control list and you have the perfect list of people who can access this Google Doc. And then trying to do the same thing in the IAM world, as I'm sure many of you know, it looks very different. So as those capabilities for describing authorization go up, it makes it harder and harder to model and harder to kind of get right. So as a fun little exercise, I'm sure a lot of you have had this sort of thought exercise before, but like can you access or delete objects in a bucket cross account? You start to think about all the things that go into play here, all the things you need to answer, and it's pretty intimidating. You get inline and attached policies, the resource policies, permission boundaries, RCPs and SCPs, default root trust, which is service specific, and then my favorite edge case is if you have a principal in an account and the principal has no permissions whatsoever. but there's a resource policy that trusts that principal explicitly, it has access. So you might look at a role or a user and say, oh, it cannot do anything. It can actually potentially do a lot. But it's very, very hard to know all of these things, keep them up to date, and then build a broad understanding of things. These are very good capabilities, though. Like, I think all of us would be hard-pressed to do our jobs if we didn't have this. There weren't many, many ways to describe the authorization story in AWS. But they also do make our jobs a little harder at times. This is an old tweet that I made back when I used Twitter. I do own the Cloud Shitposts handle, but saying my favorite programming language is IAM, not principal condition statements. And while it was meant to be kind of a joke, it does kind of ring true in that the more and more you get into the advanced features of IAM, the less and less it looks like something you can very quickly answer. It's not like a sort of static access list. It's a lot more like a programming language. And so if you want to answer questions about it, you have to be able to work with that. So, regardless of how complicated it was, we did need to still participate in this metrics program. We still needed to answer these questions. Luckily, I am not the first person to start work in this space. There's a lot of work that came before, and had every intention of using this. So Policy Simulator, the OG, I'm sure a lot of you have tried it. Surprisingly, even though it's first party, not the most accurate on simulating IAM policies and pretty clunky to use. Access Analyzer has sort of been growing over the years, higher level insights, most recently sort of like resource level insights too, if you are able to pay for them. Very expensive, can explain in a bit why we could not. PMapper is a tool I took a lot of inspiration from. It was one of the original tools that can answer some of those like who can type questions and build an access graph inside of your environment and be able to query it for things. And IAM Spy, very cool too. I know people here have probably written and or contributed to these. And I do want to stress, like, I went out and built some other tooling and like Netflix started going in a different direction. But if you have workflows that use these, I would highly recommend sticking with them because we have some unique constraints that very much so might not apply to you. Hat tip Rami. So the game plan here was wire up some tooling, make some data, move it around, make some graphs, done. So somewhere in the Jira, I have a ticket in the height of hubris that's like, this will probably take like a week. And that was in 2023. So obviously this did not take a week. Ran into some interesting challenges. So the biggest problem was that the prior art kind of fell over, and no shade at all against these tools, it just didn't really work in our environment. So the first problem was accuracy. We were using a lot of IAM features that just there wasn't support for. Performance was probably one of the biggest. Just loading the environment was very difficult. If you take all of our access policies and put them into JSON file, it's many gigabytes. And then high volume simulations. So everything worked really well, doing like thousands of simulations. Start to fall over when you get into the millions and definitely into the billions. And the last one being integration. So we wanted to connect this to some of the tools that we had, and just the way that the tools were designed, both the languages they were written in, and also just their model of operating didn't work well for that. It all kind of culminated in, I was really intent on using PMapper. I tried to get it to load the environment. I waited for like 8 hours for it to try to build this access graph. It just kind of ran out of memory. I Control-C'd out of it. I was like, okay, back to the drawing board. And I kind of came to this conclusion that there is a capability gap between the questions we want to ask of IAM and the answers our tooling can give us. Like, we needed these very simple questions, and it didn't seem like there was anything out there that could answer them very well for the environment. So part 2 of this is about closing the gap. So this is really how it felt at first. Like, just about every approach was, okay, like I need to know more and more about IAM, and you end up just getting to the point that you're re-implementing it or rebuilding it. And I want to start with kind of no shortcuts, and I ended up taking a bunch of shortcuts. So we'll talk about like the failures of this journey along the way. So the very first version of this was a tool called IAM Metrics, X. It was a Python script that focused on local IAM simulation, again, very heavily inspired by PMapper. Really just tried to answer one question so we could get these metrics kind of out of the way, which is how many principals have access to this resource. So have access, definitely a little bit more art than science, right? Like there's many different forms of access, but we were looking especially at like data plane operations, anything that will let you read, write, mutate, delete data. And started with support for tag-based conditions because we were on this ABAC journey and we were building security controls that used ABAC heavily. So it's very, very important that we could answer questions for policies that revolved around tags. But there were a lot of drawbacks. So one is missing the who and why. So we could give you a resource and give you a number of people who could access it or a number of applications that could access it. And it turns out that's actually not super useful because your next question is, well, who can do that and why can they do it? And it's like, okay, well, I can't answer that. It's a number. Limited API call support is really focused on just a few services. Same with the resource type support, like all of it was kind of hard-coded, how you pull out the policy. And just doing some very, very basic access metrics took 19 hours per run. It was not really a very agile tool, and people would come to me with questions, they'd be like, I can change something and tell you tomorrow, maybe. And it wasn't like a great iteration. So as far as like why it took 19 hours, I'll talk a lot about performance in this, but it's just kind of a numbers game where the numbers are stacked against you. So if you want to calculate access across a very, very large environment, you have your number of principals times your number of actions times your number of resources, and that's the number of simulations you have to do. So for our environment, we have well over 100,000 roles, a handful of actions if we were just talking about basic simulation, and then many, many resources. For example, if we just look at like SQS, we also have well over 100,000 SQS queues. So you do the math on that, and just to answer the question for SQS, you're looking at like somewhere between 50 and 200 billion simulations, and it doesn't really give you a lot. You want to do that across a lot of different services. You want to be able to ask different questions. Ended up being performance limited pretty quickly. So there was a second one. I cloned the script. I called it IAM Metrics 2, and just tried to butt my head against the problem a little bit more. So this was a lot of like parallelization and optimization, simulations mostly, like embarrassingly parallel problems. You can just kind of add cores to it, scale it out, and it kind of works. Added support for org-based conditions, which is another thing that we were starting to do a little bit more of, and so needed to model and then take the results, put them in the data platform. Ran into a lot of the same issues. It was a little bit better, but found that who and why is very, very important. Who is really needed for the investigation, and the why was actually a lot of debugging. So needed to know why a certain access decision was being spit out, because it is hard to have confidence in a tool that just gives you an answer and can't really tell you why, especially when you're developing it. But we did manage to get it down to 2 hours for generating these basic access metrics, which is better, but still not, it's not synchronous. You're still putting the data somewhere and then trying to answer these questions after the fact. So it felt a lot like this. So it was just kind of whack-a-mole. I would do some feature work. Someone would come back saying, hey, like, the obvious next question would be like, yes, okay, still a 20% project, so I will try to find time to work on it. I would get back like a month later. It was not fun, and it was a lot of the value of this was just gated behind feature work. So you couldn't really explore the data or manipulate it. We would constantly have to go back, do a little bit more development, support something else, and then try to re-answer it. And a lot of that is because the domain of IAM understanding has breadth and depth that is much more significant than most other access domains. So in terms of breadth, you want to pull out metrics and you want to pull out insights. Like you want a very, very broad understanding. You want to be able to step back, look at your organization, and have something point at the weird stuff or the things you should be paying attention to. Boundaries and perimeters are another good example of this that I'll talk about a little bit later. So if you want to understand like how effective is my security boundary, well, that's a very, very broad question, right? Like you're not really looking at point-to-point access at that point. You're trying to model something much larger. So some examples of questions that very actively came up at work were who can perform this API call and what has access to this resource across everything, how exposed are my critical data stores. We'll talk a lot about exposure a little bit later. And then modeling the changes, like what happens if I make this SCP change? Very, very scary. We've burned ourselves a couple times with rogue SCP changes. So it'd be nice to be able to make a change, see the effects of it, and then proceed with a little bit more confidence. There's also a lot of depth to understanding IAM. So the first is like troubleshooting. And this comes up a lot for our team. We manage most of the IAM changes at Netflix. It is one team bottlenecking many of those. And so our on-call is kind of constantly dealing with questions like, why am I getting an access denied here? Or why am I not getting an access denied here? And understanding exactly why is pretty error prone. So you have to just have a good understanding of like, well, what are all the policy layers? What do we typically do? Why might this come up? But ends up being a lot of just contextual and historical knowledge. And it is very, very hard to get that to a user fast enough, and pretty much impossible for a user to be expected to understand that by themselves. So especially where we do try to hide many aspects of the sharper edges of AWS and IAM from our users, nobody who's building an application should really be expected to know, yes, like this SCP at this layer of the OU would be resulting in this. That's where I need to go ask for a change. So all falls in a very small number of people. And so that's where this concept of a crystal ball really started to come up. So I wanted to be able to answer not just this question, but the next one and the next one and the next one, have a stronger foundation for building out some of these use cases and these workflows. If you remember the graph about like capabilities go up, ability to model goes down, really want to like have our cake and eat it too. We want to use all the features of IAM and not have that infringe on our ability to understand things. Unfortunately, that was too much work to do in the 20% project at work, so I decided to kind of strike out on my own, which is good news for you all because I created a project called Yams, which is open sourced as of today, and is really meant to address, thank you, yeah. Everybody likes code they can run, yeah. So this is primarily meant to address some of the problems at Netflix, but I don't think that those problems are 100% unique, especially to other large customers. I think you'll run into a lot of the same things, and this was kind of the foundation upon which we want to go build out and do more of this type of work. So what is Yams? Also name, a couple of people asked me where the name came from. It just, if you say IAM a lot really fast, it just starts to sound like Yam, and here we are. So Yams is a library and a server and a CLI. It was originally just going to be a library. I found that that wasn't super useful. And then it was going to be a CLI as well, and I found that that didn't scale well, and then I added a server. So it is the definition of scope creep. It's written in Go. We end up using Go for more and more of our cloud tooling, so this seemed like a good choice. Also, again, really needed the performance, so anything I could eke out a little bit faster, it seemed well worth the effort. And the goal is pretty simple, just answer these questions via simulation, be able to do it pretty quickly, and be able to build more and more workflows on top of it. So this is a very rough diagram of what this kind of looks like. You have data, which at the moment really just means AWS config. If you're not a config customer, I'm sorry. But data flows into Yams about your environment, your principles, resources, policies, accounts, org, et cetera. And then you can ask questions of it, and fully expecting the questions to be pretty diverse. So here you might have like CLI users who are doing the troubleshooting aspect of it. Like you're just on call, you're trying to answer a small question. Internal app users. We've built a lot of cloud tooling over the years and don't really want to expose yet another UI to people. Really, we don't just want to build another UI is the big issue. And so it's much nicer if it will integrate with stuff that we have today and be able to expand, enrich some of those experiences, and also just workloads. So one in the model where you don't have to worry about access to the data, you don't have to worry about loading it, you have to worry less, at least, about the scale of what you're doing, and you can just kind of hit an API and get some of the answers. So if we revisit the challenges that brought us here, these accuracy, performance, integration piece, Yams was designed to move the needle significantly on each front. It does not move the needle all the way. Like there is still plenty of work to be done, but we did want to actually be able to change the feasibility of answering these questions. So as far as accuracy, it has full support for IAM features, all different policy types, condition keys, et cetera. The performance, so again, that server model came out of mostly needing a little bit of a different way of invoking it, and especially found that it is very, very hard to answer these questions unless the data is hot. So you have all this gigabytes of JSON file, policy information. You don't really want to load that every single time you're asking a question. Also really wanted to double down on the multiprocessor parallel simulation side of things. Integration-wise, it's really built around that kind of like REST API as well as the Go library. So expecting like some people to be able to integrate with it natively. Sometimes you might have to use the REST API or the server instead. But there's a way to take a tool that you have and get it integrated into this tool. So yeah, I'd love to show you what it kind of looks like in practice. And hopefully this is pretty visible all the way at the back. I know the font size has been a bit of a problem. So this is based on the very real world, but small test environment. The account IDs, that sort of thing, are all very real. They are my personal account. Please don't go poke at them. All these examples are going to be for the CLI, but the CLI is a very naive wrapper over the REST API, so it all translates about the same. So first is you would start up a server and you'd give it some sources. And so sources are periodically refreshed. They can be local files or in S3. We keep a dump of all our config data in S3, so it's kind of built around that use case. In theory, you could expand this to just be about any source, anything you could read from, especially file-based. So whereas before, things were taking a very, very long time to load our environment and be able to even be ready to answer questions, this took about 10 seconds to load. So it was much more usable from a, like, I need to start asking things right away. You can run a stats command to see the size of sort of your universe, like when the last time the sources were updated, and also how many things that you have. You'll see like 1445 for entities. Most of that is the list of AWS managed policies that we have to pull in to be able to simulate. So the first capability is around inventory. The idea here is put all of your policy information at your fingertips. So you can list all of your principles. We'll also be truncating all the JSON just so it kind of fits here. You can query against your principles. Here we're doing a case-insensitive full-text search, so RE, green roll, red roll. If you want to see the details on any of these, you can use the -key flag, and it'll show you just a summary of the principle. So this data is as fresh as you can get it into S3. We do about 15 to 30 minutes for AWS config. Here is a similar query for a role that has a permission boundary. So you can see it at the very bottom there. But you'll also probably see that it is a reference rather than the full policy. And that's because things like the managed policies, permission boundaries, only get resolved at simulation time. It's sort of like Schrodinger's cat, like can this cat assume this IAM role, like you have to pull in the very current definition to know. So everything kind of floats up. Once we simulate it, we'll pull in all the full policy information and give you an answer back. But if you want to see that full piece, let's say you just want a deeper understanding of like what are all the effective permissions on this IAM role. You can throw on the -freeze flag and you'll see this permission boundary expanded out. And you'll also see things like accounts and SCPs get resolved at this time. So it's a way to say, for principal, for resource, show me everything that relates to it. I want to be able to see like the full universe of permissions. Same is true for resources. It's really only interesting for things with resource policies, but any other resources that you define would be in there as well. And you can also inspect the individual API calls. So I think a lot of people have worked with like the service authorization reference or those IAM actions conditions web pages. There is a programmatic version. This pulls it in and exposes it. So you can see things like what are the condition keys that would apply to this? What are the resources that this would apply to? That sort of thing. Just a little bit of an easier way to answer those questions. But what do we really build this for? It's for simulation. So this is an example of what this looks like. The sim command takes a principal action resource and gives you back a result. So was it allowed or denied, echoes some of that information. So this is like a single individual well-formed scenario. Just, I want to test this one piece out. We talked a good bit before about like breadth and the types of questions we'd have to answer there. And so this is really most useful if we can answer some of those higher level questions. So if you leave out any one of the principal action resource tuple pieces, Yams will attempt to fill it in. So in this case, we left out the principal. So Yams is going to tell you every principal that can perform this action against this resource. If we look at a resource definition with a deny-based bucket policy and an ABAC condition, this is something we do very heavily in Netflix, we can see, okay, so this, the red role that we saw earlier did have full S3 permissions against some of these buckets. And so when we see it here in the which principals can do this, it's a little bit weird to see it absent. And that's because of this deny policy. So if we remember like why, all the different policies that apply to this, we see that, okay, yes, there was a policy back there that I should recall had a allow permission. We see a deny here. You can kind of start to piece it together. But if you don't want to piece it together yourself, and that's kind of the situation we find ourselves in constantly. And so there's an explain flag, and I will try to give you the shortest possible human explanation as for why this is happening. So red role does have access to this bucket, or at least it should, except for that deny piece. So the explain flag will show you, okay, here's an explicit deny in a resource policy. There's also a trace option, which will just walk through the entire evaluation and tell you how it came to the conclusion that it did. So you can see it's going to start with the resource policies, it'll do SCPs, it'll move through everything. The output ends up being so large as to almost not be useful. But if you're very, very interested in why a particular condition is evaluating the way it is, this will tell you why. Similarly to omitting the principal, if you omit the resource and give a principal an action, Yams will tell you, okay, this is what you can access with that principal in action. And then if you omit the action, you will get a similar answer. So these are all the actions that this principal can perform against this resource. So it's an easy way to kind of like pivot around the different principles, actions, resources you have and be able to answer these questions quickly. So being able to simulate your org or the universe of things that you know is useful, but why limit yourself to things that actually exist? So one thing that my team has asked AWS for a lot in the past is, I want to understand what happens if I make this change. It's a policy change or a tag change or an account move. What happens? And so one of the things that Yams supports is the concept of overlays, where you can basically redefine your environment the way you want, pass along those redefinitions, and then get an answer back saying, okay, well, if you had made those changes, this is what would have happened. So in this example, it's much more minor than that, but here is the pulling the IAM policy definition for red role. We will make some edits. In this case, we are throwing on S3 put object ACL permission, which it did not previously have. And then we can simulate it and we can add in that overlay. So whatever you can define in that JSON file, maybe you want to change something about the account or the tags in the resource or a separate policy definition or really anything you would want to edit. And then you get the results back. And in this case, we have this put object ACL that wasn't there before. And so this is a way to be able to work towards some of those hypotheticals that we had talked about before, as far as like, what would happen if I do this? Cool. So now we have a place to ask questions. We have the data required to answer those questions and a simulator that can take the data and the logic and kind of put them together and produce something useful. It's not yet a true crystal ball. Like there's still plenty of things that come up, but it is something that feels a lot more foundationally appropriate for the questions we're trying to ask. And here are some examples of those limitations. So I mentioned like a reliance on AWS config that's very real, and we're not really sure how to solve that. We definitely don't have the ability to assume role into every account and start describing resources without hitting some very serious service limits, and just the time of that would be wild. But AWS config is missing authorization data for a handful of things. And so that does limit us pretty strongly. Inconsistencies in IAM are still very much so there. Like there are plenty of examples. There were talks at this conference about examples of that. And it's just all too common to find out that like, oh, there's like the one way that condition keys can be evaluated for this particular action, or like the multi-resource API calls, like EC2 run instances. They just have very, very different characteristics, and so it can start to get kind of clunky. It works best for direct like principal to resource interactions. But we do have this, and so if we take that and we know it's not perfect, we can at least get to the fun part and see what we can point it at to make our lives a little bit easier in a few different areas. So the first is troubleshooting. So one of the things that we constantly need is that policy info at your fingertips and where these access decisions are coming from. And so we have some self-service tooling for users, Console Me. We've talked about that at some previous conferences. And the goal is to do a little bit more integration there so that the troubleshooting aspect of before you would go make a permission request, you can understand, is the change that you're making even going to fix it? We see pretty frequently that people will like try to give themselves permissions for something that it's not actually that they don't have permissions. They're running into a control elsewhere. They're running into a permission boundary. They're running into an SCP, something like that. And especially for on-call, the ability to just move around between all these different policy types, expecting it to be pretty useful. Posture checks is another place that this has come up before. So we have the kind of standard misconfigurations that many people have, things like public resources, but there's a lot more that we want to ask. We have environments that we don't want to expose elsewhere. We want certain, I have a coworker who really wants me to use the term security invariants, and I refuse to use it, but like things like that, you're just always supposed to be true, always want to check for them. And this is a way to build out some of those checks. The two categories, I don't really think this is quite the right naming for it, but you have like algorithmic checks, like very, very, like should this be possible? Should this principal be able to access this resource? Should you be able to hit this resource from outside of this account? Those types of things. You also have heuristics. So, how many things can access this resource? Am I seeing like a large jump in it? Is there an anomaly there? Some of those more higher level questions that you may want to ask of your environment. Boundary analysis is a use case that came to me externally for somebody who is very, very interested in data perimeters specifically. For us, it's a test versus prod. Like we technically have a test and prod environment. They're not as well separated as they could be. And on the networking side, they had the ability to analyze like how much traffic goes between them. And we got very jealous of that. And I want to be able to answer the same things on the IAM side, like how much access is there from test to prod. If you can simulate enough of the principles and resources, it's actually a question you can answer. Standard and regulatory is another one. Like I think Netflix gets off pretty clean on the regulatory side. We mostly just deal with credit card processing, but other people with a more intense requirement to have strong separation and segregation between their environments can use to see how many things cross over. But most importantly, let's talk about how we got into the whole situation, which was this enterprise metrics program. So if you're a manager, get excited. This is mostly for you at this point. We've long had this difficulty of translating the value of IAM security to a larger, especially executive audience. So I am frequently in the position to summarize my team's work upwards and say like, okay, we did a lot of really, really good work that eliminated access, but you have to read these like 3 paragraphs to understand exactly why and how far. And it doesn't really do the work justice. And so what we really have wanted for a long time is this like KPI for cloud access. Like, can we just look at a couple of metrics and tell you how the program is doing, or describe these projects and like the effects that they are making? So there's 2 concepts we're going to talk about briefly, which are exposure and efficiency. So exposure is pretty simple. How many principals can access this resource? So a measure of how much access coming into a particular resource is there. And this number is very contextual. In some cases, it should probably be 0. In some cases, it might be like 5,000, and that's expected. That's great. Only you really know what the exposure of various resources should be. And there's probably a lot of ways you would want to slice that data. Efficiency is one that's also very interesting. So if you take exposure and put it as the denominator, and the numerator is how many principals need to or currently are accessing a resource, you start to build this idea around like how close to right-sized access am I? So if 5 principals need access to it and 5 principals have access, your efficiency is 1 or 100%. You're doing great cloud security. If 1 principal needs to access it and or let's say 10 principals need to access it and 1,000 can, your efficiency is 0.01 or 1%. And you're very, very, very far from right-sized access. And so these metrics are useful because they're intuitive and they're pretty easy to understand. Like you would want exposure. You hear that word, you want it to go down. Efficiency is always a good thing, you want it to go up. So you can intuit about where you would want these different pieces of your IAM story to go. So how do you get these numbers? Exposure, Yams was kind of meant to solve one of those big pieces, but also any other IAM analysis tools. How many principals are or need to access this resource is tough. If you can use CloudTrail and data events, do it. That is by far the best way. We absolutely cannot afford data events. So we gave a talk at reInvent 2022 about instrumenting SDKs as our way of data events for cheap, but with gaps. But maybe you also have org context on this, and you can start to say like, oh yeah, these tagged resources are supposed to be locked down. This is what access is supposed to look like in this environment. Like I'm comfortable with certain thresholds. And those translate very, very nicely into OKRs, which was also a big motivator for doing this. So here are some examples of the types of OKRs that we've wanted to write for a very long time. One of them is about like average access exposure in environment. It's always a number you want to drive down, right? You can understand it in aggregate, and you can report on the measure of success of you doing IAM on that number trending downwards. Or maybe it's more targeted, like your sensitive data stores, or like a particular bucket, where you want very, very high efficiency, very, very low exposure overall. Things shouldn't have access to your critical data stores unless it's actually needed. And you can actually quantify that and say, yes, we're either very close to or far away from the goal. Maybe you want to look at the prod environment's exposure to test, like I mentioned before, or maybe you want to look at the IAM roles that are available to many, many people and say, like, we want those to be more efficient. If we're giving out roles to a bunch of different people who work at the company, they shouldn't have a lot of permissions that they don't need, and you can start to measure it and move closer to something. I have some colleagues, this conference's own Patrick Sanders and Joseph as well, who gave a talk at reInvent last year talking about some of these things. So this was like using the concept of exposure to chart the progress and the impact of account migrations. Whereas normally you'd say like, yes, we're moving things out of the big count, it's a good thing, trust us. You can also really start to quantify that and say like, there's one key metric we are looking to drive down, and it's this concept of exposure. So what is next for this work? The first thing is integrating more deeply with Netflix tooling. We're still mostly on that like IAM Metrics v2. I would love this to be pulled almost like reverse open source back into Netflix to solve these problems. Performance is still a thing. It's not chasing performance for performance sake, but want to be able to do more things. Be able to calculate data and throw it away. If we don't need it, compute should be pretty cheap. We want to be able to answer more things synchronously instead of asynchronously, and have on-demand answers. So I've talked a lot with teammates about this, but like if you go view a resource or you're looking at a resource or an IAM policy change, being able to see the effect of it, or you're seeing someone's requesting access to a resource and that resource is very, very minimally exposed or extremely locked down, you should be able to just see a green number or red number to help you understand contextually what's happening inside of that request. The real goal overall is that AWS provides this. Like there have been not one, not two, but 3 talks at this conference about making, understanding IAM more. It doesn't really make sense for people to keep building these tools when like AWS has this, they can answer 100% accurately and probably do it better than any of us. But we're still, yeah. But if you're interested in this, I highly recommend David Kerber's talk from yesterday and Jason Cow's talk from today about just like You probably are making mistakes in IAM or need to understand it better. Here are tools to try to help with that. We do need more first-party support. Yeah, so that is it. Things are available at ncao.github.io/yams. I want to leave a little bit of time for questions, ideas, light roasts, whatever we have. But thank you for staying, and hope this was as fun to hear about as it was to build.
Thanks, Nick. We do have a couple of questions in the room. The first one I think you did cover, does Yams require a server or can you do the CLI standalone?
You can kind of do the CLI standalone. You'd have to run a server locally. So you do need some server running.
Got it.
Yeah.
And then Eli asked, does the overlay let you evaluate across your entire policy universe to the scenario of what would happen if I did this? Being able to evaluate the effect of SCP changes across all principles would be super cool.
Yes, that's actually the exact use case it was built for, which is you would redefine the SCP, the policy, write it whatever you want it to be, and then start asking questions based on that.
And there's one more question, probably easier for you to look in there. All right, do we have questions in the room? No. I have a personal question. Why didn't you invent this when I was still doing cloud security assessments?
Hi, thank you for the talk. It's very interesting. I won't. So hypothetically, if you had an environment the size of Netflix, how long do these simulations take to run?
Yeah, so a lot of that really depends on the scope of it. So it's that like number of principles, actions, and resources. And so for the very, very basic things that we were doing before, which is very small number of actions, only like 3 or 4 resource types, it takes about 15 to 30 minutes, just kind of depending. That is, the deployment strategy for this for Netflix is go put it on a 128 core EC2 and just let it rip, because like that's all we really know how to do.
I'm Chris Coleman. Did you go into why you're limited by AWS config data, or like why you're limited to AWS config data? Did I miss that part?
I covered it very briefly, but the short answer is just too many resources to describe very effectively.
Got it.
And then contention for those described APIs, because we have some other talks that talk about this, but like we're concentrating a very small number of accounts. And so like service queries for those describes are very limited. And we found that you try to describe a bunch, by the time you finish, one, your data's stale, so you just kind of have to go back to the beginning. But it's mostly just pagining through hundreds and thousands to low millions of resources.
And you don't have to answer this, but if that only took you 1 week, what are you up to next week?
Yeah. Did not take it. Took a year.
Any other questions? Oh, in the back of the room, of course.
Did you end up having to essentially rewrite IAM, or is there any reusing of the simulator or anything else like that?
No, it's just rewriting IAM and Go pretty much. I think that's the approach that I think a few projects have had to take. AWS, if you could release a library to do it locally, that would be extremely useful for so many of us.
Are you taking orders on what other parts of AWS to rewrite?
Yeah.
Okay. We had some more questions. Oh, nope, one was already asked verbally. And this is amazing. Have you thought about rooting this in real human identity, i.e. Okta Principal, Fifth Identity Center, et cetera?
Yeah, I think that's been the most common question. And ideally, yes, but don't really know how. So I think there have to be some abstraction over what does human access to an AWS principal look like, and genericized enough to be able to do this with whatever your identity provider is. I understand like for many people it's just group membership, LDAP, AD, Google Groups, that type of thing, but I think there's something there, just not really sure how to crack it yet.
Great job on this. So you talk a lot about the principal to resource and what that kind of simulation looks like. I'm curious on whether you have considered like some of the resource to resource interactions, like S3 to SNS, or like SNS to SQS subscription, or some of those like permissions that are direct service to service interactions or through AWS services?
Yeah, again, I think there's something there, but not entirely sure how to model it. Like, I think that resource to resource for things that are, source error in conditions starts to become a little bit more straightforward. But when you talk about like trusting account routes, or especially like service linked roles that get used by a service for something else, I think that mapping is a little bit more difficult. So I'm gonna punt on that one for the future.
All right, thank you, everyone. We will kick off again. It's break time at 3:10 or 15:10.